Yes, hi everyone. Good morning. All right. So, from today onwards, we are going to start with our very important part, which is your machine learning, right? So, what I'll do is on your drive, I'll just create a Google Sheet, and in that we are going to discuss everything related to machine learning, right? So theoretical point we are going to discuss in this particular Google Sheet. So you already have your drive link, right? You can open this so that you can also be able to see that and revise from this thing, right? Okay. All right. So uh, the very first thing is, let us try to understand the structure of this course, right? We have predictive analytics with us. We have predictive analytics with us. Uh, Previously, we have completed EDA and statistics part. So in that, we have seen how do we visualize the data, right? How do we clean data? How do we perform data? Visualizing the data. How do we clean the data? And how do we perform EDA? We already have discussed this, right? Now, coming towards your CRISP DM framework for a data science model or ML model. So what was the steps that we were having? What were the different steps? So first step was business understanding. Second was data understanding. Third is data preparation. Fourth is model building. Fifth is model evaluation. Sixth is model deployment, right? These are the different steps of any machine learning uh, project, right? Just a minute, just right. So these are different steps of any machine learning models. Now, business understanding, data understanding, and data preparation comes under your ED and statistics, which we already have discussed this part, right? So this comes under here, and the model building part, model evaluation, and model deployment are the next stages that we have not discussed, right? So what is predictive analytics? What is predictive analytics? So it uses cleaned and prepared data and build the models. Simple, right? So in that you have linear regression. These two stages, model building and model evaluation, these two stages that we have comes under your predictive analytics. Model building and model evaluations comes under your predictive analytics. So in that, predominantly we are going to have in predictive analytics, we are having linear regression, right? We have logistic regression. These are the machine learning models. We have clustering approach and we have PCA, right? So these are the main important steps that we can perform in our predictive analytics, right? Now, moving further, in linear regression, when it comes to linear regression, it is one of the most widely used model, and it is used for linear regression, linear relationship, right? When it comes to logic regression, it is used to predict class or category, and it is also one of the widely used model for classification. What is classification? What is regression? We'll discuss that in more detailed manner after some time. And then we have clustering. What do you mean by clustering? It is known as customer segmentation. Like you uh, s- customer segmentation. You just try to group different customers into different label, right? So exploring in absence of labeled data. And we have PCA. It is used to perform dimensionality reduction. So this summarizes your entire predictive analytics model, right? Now, uh, what are the prerequisite? You don't need to have any prerequisite for linear regression, logistic regression, clustering. You only need to have a good knowledge of your equation of a line. That's all, right? So you just need to have a good understanding of an equation of a line. Now, introduction to, we'll just try to understand what is linear regression is, right? So linear regression, as the name suggests, it is nothing but a line, right? It is related to linear relationship of the data, right? So what we are going to see is, in this session, we are going to see simple linear regression, and we are going to see multiple linear regression, right? Now, in this session, you'll you'll get a quick introduction of machine learning models. You'll also learn about basics of simple linear regression, how to find best fitted line for a model, and all the various parameters associated with it. The broad agenda for this session is as follows. We are going to uh, uh, discuss, we are going to have introduction to machine learning. We'll see what is supervised and unsupervised machine learning. Unsupervised machine learning. We'll see the linear regression model. We'll see residuals, and we'll see residual sum of square, that is RSS. Residual sum of squares, that is RSS, and the R squared. Simple. What is R squared or R2 squared, right? So that is what we have. Now, let us understand the, let us have an introduction to machine learning, the first part. So what is machine learning is? So you all know the different applications of machine learning, right from your, we have Siri and we have Google Assistant in your phone. You just, what do you do is you just put a command, like say, for an example, you want to call your mother, right? So you just say, hey Siri, and you have a conversation with that particular assistant, right? So that is an example of your machine learning, first part. Second is autonomous car driving. Everybody knows that. Autonomous car. That is also another example of machine learning. But this just comprises of only your household applications, or only applications which are related to human. But what about your your co your business perspective, right? For example, let's say uh, you have one hospital, and for an example, you are working as an analyst or data scientist in that particular hospital. What is your task will be? You will be having different beds, right? Bed 1, bed 2, bed 3, and bed 4, right? And you will be having different patients, they are in the particular queue, right? So they have filled forms, and they have completed their formalities. They have registered themselves by filling the forms, and it's your task to just allocate the users to the respective bed, right? So how we generally do this, depending upon the critical situation, depending upon the severity of the disease or the situation, we allocate them these patients to particular bed, right? So this thing nowadays happens with the help of machine learning. So you don't need to actually go and check if that bed is vacant or not. What do you do is you have a database in your system wherever there will be different beds and different patients, and depending upon the severity, you directly allocate that patient to that particular bed, right? Apart from this, you have n number of applications. It's not necessary to discuss that. You might already be aware about that. So let us move to the next part now, right? Now, your modeling uses machine learning algorithms in which the machine learns from the data, just like humans learn from their experience, right? Now let's go deeper into the types of model that we have. Types of models that come under machine learning. So we have different types of models, like we have a first part, which is regression. We have second part, that is classification, and we have third part, that is your clustering. Apart from this, you will not come across any type of problem in your machine learning. All the machine learning approaches will become confined to these three spaces, right? So in regression, your output variable, I could say your output variable is output should be yeah. Your output variable to be predicted is a continuous variable. Yes or no? For an example, scores of a student. For an example, you are building a model which will predict scores of a student based on their class 10 mark, right? So scores of student can only be in numbers, right? It can be 80, it can be 75, it can be 98, right? So can it be a text? It cannot be a text. Here we are talking about scores, right? We are not talking about grades. So whenever your target variable, your output variable to be predicted is a continuous variable. What do you mean by continuous? A number. So that is your regression type of problem. Then you have classification. Whenever your output variable is to be predicted, is a categorical variable. Is a categorical variable. So for an example, you're classifying an email, incoming email, as spam or ham, not spam, right? Then you have clustering, where you'll not be having predefined notion of a label. So it is often observed that we allocate to different groups. It is allocated to groups or clusters formed, right? For an example, you can have example as customer segmentation. You segment customers in different groups, right? So you'll get to know more about different types of machine learning models in the coming sessions. Let us now learn about what is supervised and unsupervised machine learning, right? So machine learning gets classified predominantly into two types. First is your supervised, second is your unsupervised machine learning. What do you mean by supervised? You have past data, you have past data with labels, and it is used for building the model, right? Uh, in supervised, you have two types, regression and classification, right? You have past data, which is nothing but your labels that is used for building the model, right? But in unsupervised machine learning, you will not be having no predefined labels are assigned to input data, right? No predefined user labels are assigned to the input data. And how do you solve this? By using clustering algorithms. So clustering algorithms that we have discussed fall under this criteria, fall under this category, right? So clustering example, if you are not able to get this, we'll just see what is clustering is. So you segregate data into different clusters like this. Can you see this? Where we'll not having any label data. Simply what we'll do is, we suppose you have this data, you put that into algorithm, and this algorithm will classify into three groups. Let's say first group is orange, second is strawberry, and third is grapes, right? So it is just like classification. It's just like you're segmenting data into different groups or clusters. So is it clear now, everyone? Is that fine till now?
Yes, sir.
So for each problem, to identify if the task can be addressed by supervised learning or unsupervised learning, you uh, you assume an appropriate data set is available for your algorithm to learn from. So you get a data, and from that data itself, you get an understanding if the data is labeled, if the data has target variable, it is an unsupervised problem statement. If the data does not have labels, it is an unsupervised. If it is labeled, it is supervised, right? Now in the next segment, we'll learn about the regression line. So what I'll do is I will create a new sheet for linear regression, and let us try to understand very simple and very useful machine learning model. And by just trying to understand what this model is, you guys will be getting I would say 60 to 70% of the information about the machine learning world, right? So let us try to understand regression. What is regression line? Now in the previous segment, you learn about different types of classification and machine learning model. Let us try to understand what is regression. So for example, let's say you run a marketing company, right? And on x-axis you have sales in uh, crores, and on y-axis you have, let's say on x-axis you have marketing budget in lakhs, and on your y-axis you have uh, sales in crores, right? CRORES, sales in crores, right? So our problem statement is, depending upon the marketing budget that we have, what will be our sales? So suppose if I invest 10 lakhs, my sale is coming out to be, let's say, uh, 12 crore. If I invest 25 lakhs, it is 18 crore. And so I'll just put a random data, right? Suppose here it is 17, here it is 16, here it is 17, here it is 15, here it is 13, it is 12. So just a random data, and what I'll do is I'll just take this and I'll try to insert chart, right? Scatter plot. So this is your scatter plot for that particular data. Now what we'll do is we will try to uh, we'll try to understand regression line. So on this data, I will just draw a line which will try to fit all the data points, right? So any random line you can plot, but obviously uh, this particular data point will be having one regression line which will try to fit all the models out there, and that particular regression line will be having an equation. Yes or no? And what is the equation of a line then? What is your equation of a line, guys? Equation of a straight line. It is y is equals to mx plus c, right? So suppose I'll just remove this. Suppose you have one line, you have one line. This is your line. And the equation of that line is equal to is nothing but y is equals to mx plus c, and m nothing but is your tan theta, this angle with respect to this line, and horizontal x-axis is your theta. Uh, then your next part is your c. What is this c? C is nothing but the point, the distance from the y-axis, distance from the origin, and wherever this line intersects to the y-axis, right? Wherever this line intersects to the y-axis, that particular distance from the origin, that is your c. Yes or no? Everybody knows this equation. I'm just revising this. Now, what is the importance of m and c? First point, m is your slope, right? So for every unit on x-axis, what do you have? Marketing budget, right? On y-axis, you have sales in crores. So for every unit increment, every 1 lakh spent on my marketing budget, what will be the sales in 1 crore, or what will be the sales? That is taken care by this slope m. So for every unit change in my marketing spend, what will be the sale? This m, your slope, will explain that particular point. Yes or no? And what is c? What do you feel? What is c? How your c will help you out? What is c? C is nothing but if your marketing budget is zero, let's say 0 lakh, even though you will be having some sales, right? Yes or no? So for suppose your marketing budget is 0 lakh, for that particular marketing budget, your sales is, let's say, 5 crore. So that tells you the importance of the intercept. Is that clear? The equation of a straight line, how it helps you out? So we have M and C. This will help you out in different ways. Now, a simple linear regression model, a simple linear regression model, it attempts to explain relationship between your dependent variable and independent variable by using a straight line. right? Now you will ask this question, what is dependent variable, what is independent variable? Now in this example, what we are trying to predict is, what we are trying to predict here, we are trying to predict sales in crores, right? By using marketing budget. So your target variable, your dependent variable, your output variable is nothing but is the variable that you want to predict. In this thing, sales is your target variable. Yes or no? And you have other variables which is known as independent variable, or it is also known as predictor, which we use to predict the target variable is your marketing budget here. Is your marketing budget. Yes or no, guys? Now you have to unmute and speak because this will be your interactive session. Today's session is where it should be interactive. So I'll not understand if you guys don't unmute and speak. You should ask your maximum questions here itself, right? This will be your very important session. So your target variable is sales. The variable that you want to predict is the sales over here. And the variable that we are using to predict the target variable is your independent variable, that is marketing budget, right? Now, there is no any need that you will having only single independent variable. Yes or no? You might have n number of independent variables, and every time you only have one target variable. So the target variable can only be one, because at a time we can predict only one variable. But independent variable, it can be anything, right? It can be 5, it can be 10, it can be 100. So multiple independent variables we can have. But remember, your target variable, it has to be one only. Yes or no? Now, whenever you have this type of problem statement, this is known as simple linear regression. What do you mean by simple linear regression? When you have only one independent variable. That is a simple linear regression. And what about multiple linear regression? What do you think? What is multiple linear regression? Yes, guys.
Multiple target variables.
Not target. Have I told target variable? It can be multiple.
No, sir.
Right. So multiple independent variables, no? Yes or no?
Yes, sir. Yes.
See, the variable that we use to predict the target variable is known as independent variable. So marketing budget is your independent variable. Sales is your target variable or the dependent variable. Okay, to just make you clear, we'll just take simple example. Let's say I have one car. Not I have one. I have a data set in which I want to predict mileage of a car. Right? I want to predict mileage of a car. So I have car CC, I have car weight, number of gears that car has. I have a particular model, whether it's petrol or diesel, right? And whether it's V engine or C engine or anything, I have this much data set. So first question to you, is it simple linear regression or multiple linear regression?
Multiple linear regression, sir.
Right. And second question, what is your target variable?
Mileage.
Very good. Mileage is the one that you want to predict. So it is your target variable. And what are your independent variables?
CC, weight, number of gas, petrol, and VC engine.
Very good. And why this is regression? Why it is not classification?
We are predicting a number, sir. We are not predicting a object.
Very good. Very good. Excellent. So our target variable is a continuous, right? It is a number. Just try to put this habit continuous. You should say continuous because it's more technical word rather than number. Number is also fine, but you can say continuous. And whenever your target variable is categorical, then that is a classification problem, right? So I'll just put 5 examples. Let's say I want to predict price of a bike. You should tell me whether it's classification or regression. I want to predict whether customer will get loan or not. I want to predict temperature of a city, particular city. And I want to predict whether customer will be having diabetes or not. And I want to predict uh, city from which a particular customer will belong. Chalo. What do you think first problem statement? What is it? First
Regression.
problem. Price of a bike. Is it regression or classification?
Regressions.
What about second?
Classification.
Why it is classification?
Because we are predicting if the it's yes or no, sir. It's not a continuous variable. It's
Yes.
categorical.
Yes. So your target variable, the variable that we are going to predict, is numbers over here, right? But in this second example, it is nothing but whether customer will get loan or not. It is yes or no, right? Output should be yes or no, or true or false, right? What about second, third? Predict temperature of a city.
Regressions.
What about fourth?
Classification.
Because to predict whether customer will be having diabetes or not, we have yes or no, right? And what about fifth? To predict city from which a particular customer will belong. It is also.
Classifications.
So we suppose we have different cities, like in our data set we have different cities like Pune, Mumbai, Delhi, Bangalore, Kolkata, and Chennai, suppose. Right? So we only have this much cities. Apart from this, we don't have in our data set. So labels, how do we how many labels do we have? 1, 2, 3, 4, 5, 6. We have 6 labels. So it is also classification, right? It is multi-class. It is known as multi-class classification. Multi-class classification. Why multi-class? Because more than 2 classes are there. No, here we have yes or no. So only 2 classes means it is only binary classification. It is known as binary classification. And whenever the classes that we have are more than two, that is known as multi-class classification. So likewise, you can just take this Google sheet and you can write down n number of example which are there as part of your classification and regression. Yes or no? Now let's understand best fit line. So in regression, there is a notion of a best fit line which fits a given scatter plot in the best way. Which fits the given scatter plot in the best way, right? So this is my scatter plot. And suppose this is my best fit line. So I'll just copy this and I'll paste it over here, right? Apart from this, you can draw any lines, right? You can draw this line, you can draw this line, this line, this line. N number of lines will be there. So what is the best fit line, right? What is the best fit line? So to understand this, we should understand the concept of residuals. Residuals first. So what I will do is just best fit line. Hmm. You can take this. This is also good. Or this. Okay, this seems good. So let's take this image and let us try to understand what is a best fit line. See, best fit line will be having, to understand best fit line, you should understand residual first. Residual first. And you should understand sum of squared residual. So that is also known as residual sum of square. Residual sum of squares, that is RSS. Residual sum of squares, right? So what is residual sum of square? See, uh, suppose you have this data point, you have drawn a line, and this line will be having some errors, right? This line shows this line is nothing but predicted values. Like, uh, it gives you the idea. Suppose on x-axis you have marketing budget and on y-axis you have sales. So suppose for a particular marketing budget, let's say 50 lakhs, what will be the sales? What will be sales in crores? This will tell me by this we'll get an idea about this by using the regression line, right? So any number, let's say my marketing budget is 80 lakh. So what will be the sales in crore? Or suppose it is this. So what will be this? I'll get this idea by using regression line. Yes or no? But at these data points are known as observed value. That is your actual values. You have actual data, you have a data, you plot that on your x and y axis. These are the actual data, right? And this is a predicted value, this one. So there is concept which is known as residual or error. For an example, for an example, let's say your marketing budget is, here it is 50 lakh for an example. Your your line, your regression line says it should be 20 crore, but actually it is 40 crore, right? So your regression line is making this error, yes or no? Your regression line is making this error of 20 crores. Do you agree with this point?
Yes, sir.
So similarly, suppose here it is 70 lakhs for marketing budget, 70 lakh. Your model has predicted 50 crores and your actual value is also 50 crore. So is there any error between your actual and predicted values? Is there any error? No error, right? Because actual and predicted are zero, right? So similarly, we'll be having multiple errors like this one, then this one, right? So I can say the best fit line is the line which has the minimum residual sum of squares, or minimum residual or minimum error, right? So the best fit line, we can add a definition which fits a given scatter plot in the best way, or which has the minimum error or residual. These are nothing but same word, right? So this is what we have for the best fit line, and why there is a need of a your residual sum of squares. Why we should not only calculate the error. why we should only, why we should not do the summation of the error. So the thing what happens is, your error term is nothing but actual minus predicted, right? So suppose you have a data where the actual value is 40 crores, but predicted is 45. Your actual value is 50, predicted is 45. Actual is 56, predicted is 48. Actual value is 57, predicted is, let's say, 59. Actual is, let's say, 60, predicted is 52. Actual is 65, predicted is 75, right? So let us calculate residual. What I told you is, it should be actual minus predicted. So actual minus predicted, right? So this is minus 5. And if I just autocomplete this, I'll get the error, right? So sometimes it is positive, sometimes it is negative. Yes or no? Sometimes it is positive, sometimes it is negative, right? So if I just calculate sum, simply a sum of this residual, here it is minus 4, right? Here it is minus 4, or here it is 0. But in actual sense, my model, my regression line is making some error, right? But if I just simply calculate the sum of the residual, only sum of residual, it's a 0. So negative and positive will cancel each other, right? This is positive, but the data point, if it is below to the regression line, this is negative error. Simple. So there will be a chance. There will be a chance if my residual will cancel each other and it will be 0. So that's why we take residual sum of square of a residual, right? So minus 5 become plus, right? If I just take square, 25, 25, 64, 4, 64, and 4. And then I'll calculate sum. This is known as sum of residual sum of squares, right? It is 186. And this will tell me an idea about the error, right? This will tell me an idea about the error. Yes or no? But again, there is one problem, that this magnitude of 186 is very high, right? Because my error was in only one digit, minus 5, 5, 8, minus 2, minus 8. But here error says it is 186. It is very high on a scale. Suppose on a scale, your error lies over here, but your sum of residual square error scale is very high here, right? So what I have to do is, I have to take average of these values. Again, it is high, 31. And then I have to take square root of this average, right? Now it is 5.56, and which is in this sense. So generally, residual sum of squares also we use, but to be very precise, it should be in the same unit as in the form of error or residuals. It has to be in the same unit of that particular residue. So we take root mean square error. So that is your another thing which is known as RMSC, which will be very, very important for you. So why do we take RMSC? It's an entire story plot that I have told you over here. The residual negative and positive can cancel each other, so we have to take square of the residual, but this will not lie in a same range, so we have to take we have to take average of that. But again, by taking average, we'll not be able to get it in the same digit, so we take root mean square error, and that's why RMSE comes into the picture, right? Is that fine, guys, till now? Because I'm going to go in deep now, and it will be a more technical discussion now from this point onwards. So if you have any questions now, you can ask. Otherwise, we'll go to the next part. Yes. Anybody have any questions?
If that value is negative, right? So you're squaring it to positive. So we shouldn't consider that negative value in the residual.
That is just a magnitude, right?
Mm.
Minus 2 and plus 2. That is just a magnitude.
Okay.
So this is positive, this is negative. That's all. Anyway, what we are doing is we are finding error, no? So
Mm.
plus 2 error and minus 2 error. That's all. So it will not affect.
Okay.
It's very simple mathematics. Like this is not the thing that you guys will be learning now. If you remember your old school days, you have learned this concept. Best fit in your I think physics. So do we have for machine learning? Do we have another tool application or will Google Sheet or for this? No, no. Machine learning we are going to use Jupyter Notebook, no, or Google Colab coding part. This is just theoretical part that we are discussing. I'm just explaining you the important theoretical discussion. Anyway, we everything we go and do it by using codes, right? So we don't have to do it in Sheet, Google Sheet, right? Now I'll introduce one fancy term to you, which is known as cost function, and you should always remember this. What is cost function? So in this thing, I'll tell you residual residual sum of squares, that is RSS, is your cost function. Is your cost function. Residual sum of square, that is RSS, is your cost function over here, right? Or your RMSC is your cost function. And what is cost function? In simple words, I'll tell you. Cost function is nothing but this function we have to minimize to get the best fit line, right? And anyway, residual sum of squares is your error term, right? It has to be minimum for the best fit line. Yes or no? Or your root means square error. It has to be minimum for the best fit line, isn't it? It has to be minimum for the best fit line. Yes or no? Error has to be minimum, right? So cost function, you have to minimize your cost function. Remember this. In your entire machine learning journey, you'll come across this point of cost function, and we have to minimize the cost function. So for different models, different machine learning models will be having different cost functions, isn't it? So very simple discussion that we have to minimize the cost function because it's an error to get the best fit line. Now, what is gradient descent? We will come across this very important term in logistic regression, in your neural networks, right? So at this point of time, that's the reason I am not discussing this in more detailed fashion, because it has a lot of mathematics associated with that. And if we just discuss now, you guys will feel difficult as of now, right? So it has to be stepwise. That's the reason this cost function we are going to discuss after some sessions whenever we are going to discuss logistic regression and neural networks, right? Now you can learn about cost function and the ways to optimize cost function by your own, minimization and maximization. This topic I can share you link for that, but I will suggest you to not go in depth as of now because we are just understanding simple linear regression, right? So what is gradient descent, or how do we minimize the cost function, that is RSS over here in machine learning, in linear regression? There are two ways. One way is to differentiate and equate it with the zero. That's how we used to get minima in our mathematics, if you remember that. A second is gradient descent, and this is very important term as far as your interviews are concerned. So remember, this should be very important for your interviews. So there are two ways. that you can use to minimize the cost function. Simple. Now, how do you find the strength of the simple linear regression? How do you find the strength of the simple linear regression? Again, very important part. So after determining the best fit line, you have calculated the best fit line, which has the minimum error. So there are few critical questions you need to answer. First question is, how well does the best fit line represent the scatter plot? Second point is, how well does the best fit line predict the new data? Simple. So you have to answer these two questions. How well does the best fit line represent the scatter plot? And how well does the best fit line predicts the new data? Right? So to understand this, we should understand two terms, residual sum of square and total sum of squares. And there's one more thing which is very, very important, which is known as R2 score or R squared. We'll just try to understand what does that mean, right? So what we'll do is we'll just try to understand the residual sum of squares or R squared. So suppose this is your line and this is your data. So 1, 2, 3, 4, 5, 6. And this is known as residual. So this is residual, error, and residual. So residual or error, right? What is your residual sum of squares? You will take square of this, because this is minus. So you have to take square, square, and you just add. That is the residual sum of square, right? Right? This is RSS. Everybody knows this. But what about total sum of squares? Right? So what I've done is, what we generally do is, this is your line. This is average of that data point, average of the data. Suppose it is 7.5 crores, right? And you have data which is here, which is here, 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 and here. So this is your line, this is your best fit line, but you'll find distance between the average point and the data points. You'll find different distance between average point and the data. So you'll not find distance between your regression line and your uh, data points. That is your RSS. What is your total sum of squares? This distance you'll take square, you'll take square, and it will be total sum of squares. Isn't it? It will be total sum of squares. So for this equation of a line y is equals to mx plus c, so what we'll do is, for different x, for different m value, for different c value, we'll just visualize this concept, which I just have told you, right? So just give me a minute. I'll just share one visualization tool with you, and we can play with that particular data to understand the total sum of squares and your residual sum of squares, right? So just a minute. So that particular, yeah. Okay, I'll just share this. See now, we have an equation, right? Y is equals to mx plus c. Yes or no? Uh, what in more detailed fashion or in more technical sense, what do they do is they write down y is equals to beta 0 plus beta 1 x, right? So beta 0, if you compare, that becomes C, beta 1 becomes M, right? So for different value of beta 0, if I just change, your line changes, right? Right? For different value, your line changes. So beta 0 is your C and beta 1 is your slope. So if I just add a slope, it becomes very steep, right? Slope, if I just change slope, it becomes, and as I told, the residual will become distance between, it is nothing but distance between your regression line and the data, right? But for total sum of squares, TSS, if I just say show TSS, it will calculate the distance between the average of that particular data and the data points. So there is no discussion of the regression line over here, right? So for total sum of squares, there will be a distance between your mean and the data point. And for residual sum of square, it will be a distance between the regression line and the data point, right? And if I just say show TSS and residual, if I just say show TSS and residual, it will show TSS as well as residual over there. So residual is 200, TSS is 680.86, right? Residual is 200 and it is 680.86. Yes or no? Is it clear, this point? Now what we'll do is I'll introduce a new term. We have understood TSS and RSS. Now it's time to understand what is R2 squared and R2 score. So it is also known as R2 squared, or it is also known as R2 score. So its formula is 1 minus RSS divided by TSS. 1 minus RSS divided by TSS. That is a formula, right? So remember, your R2 score will tell you, will give you an idea about the strength of the linear regression, and R2 score is just like your, in simple word, it's just like your accuracy of the machine learning model, right? So accuracy lies from 0 to 1, right? It should be in between 0 to 1, right? So my accuracy can be 0. If it is a 0, it is a poor model. If it is 1, it is very best model, right? So it has to be near to 1 for the good model. The nearer the value of the accuracy or R2 score is towards the 1, I can say that as the uh, it's my good model or the best model. Yes or no? So remember, R2 score has to be as maximum as possible. And in simple word, it tells you the accuracy of the model. But if you want a clear definition of R2 score, it goes like this, that it's the ability of the independent variable to predict the target variable, right? So if I say my R2 score is 0.8, it means my uh, independent variables, are 80% capable to predict the target variable. Simple. My independent variables are 80% capable to predict the target variable. Now, is this thing clear to you? What is R2 score? What is RSS? What is RMSC? Is it clear, guys? So it gives you strength of the simple linear regression. So we have completed a basic model of what linear regression is and how to find the strength of the linear regression. Now what I'll do is I will what we'll do is we'll go to the coding part now, right? We'll go to coding and understand how to fit the simple linear regression model in Python, right? And somebody has asked me, can you explain again what is best fit line? Best fit line, I have told you, right? What is a best fit line? Is the line. Best fit means the sum of the square of the vertical distance from each point to the line is minimum. So best fit line is the one which has the minimum residual or minimum residual sum of square RSS. So suppose I have this line, these are the data points, right? Again, I have plotted another line. I have plotted another line, this line. Again, I have plotted another line, this line. So what we'll do is for all the lines, we don't actually calculate the residual manually. Everything will be done in Python. So you don't need to worry about that. But I'm just explaining how this model works in the backend. So the best fit line is the line to understand the difference between best fit line is the line which will be having a minimum residual sum of squares or minimum error, right? And I also have discussed RSS and TSS. So I'll ask this question instead of you guys are asking this to me. Who will tell me what is the difference between RSS and TSS? Yes, come on, guys. What is the difference between RSS and TSS?
The RSS, we are finding the difference between the data points and the best fit line, sir. In TSS, we are finding the difference between the data points and the mean line, average line.
Right, simple. Is it clear now, Prashant?
Yes, people.
Yeah, it's clear, right, Prashant?
Yes, clear, clear.
So basically, what is RSS is? It is a distance sum of the residual. I mean, its full form is residual sum of square. What do we do is we calculate the distance between the data point and the regression line, right? But in case of TSS, total sum of squares, it gives you a variation of data around the mean. So we don't calculate distance between the data points and the mean and the regression line. In TSS, we calculate the distance between the data point and the mean. So we have a mean term over here. Simple. And we have 1 by RSS divided by TSS. That will be your R squared or R2 score. So R2 score formula, if you just see, 1 minus sum of residual square divided by total square. Simple. So it nullifies the effect. It has a lot of mathematics, but just remember, it is not an absolute quantity. It is uh, it's a good quantity as compared to other. Residual sum of square is also not good. Total sum of square is also not good. So we take R2 score to find the strength of the strength of the best fit line. Simple. Strength of the best fit line. Right? Now, we'll do this coding now, but before that, let's have a break for 10 minutes. So it's 10:12. We'll be back somewhere around 10:24. And we'll just see how to fit the best fit, how to fit the line. Sorry, how to fit this model by taking out an example in Python, right? So we'll do coding now. Yes, what I'll do is now I'll share a data set with you on your drive. Just let me know if it is done. You just download that, let me know if it is done, and we'll start with the model building part. So on your drive, if you just see, I have uploaded a data set. Name of the data set is car MPG students, this one. And this is your collab link, right? So if you want to do this simultaneously with me, you can do this. Or if you just want to observe, you can also do that. But I'll suggest you to do this simultaneously with me so that your first practice of this will be completed, right? And you have to practice this multiple times in order to get confident in model building part. So unless and until you don't practice, this will not be easy for you, right? So I'll suggest you to go ahead and do this thing with me. All right. So as we have discussed the basics of machine learning, we'll not discuss what is regression, classification, what is supervised and supervised. We'll directly start with the importing necessary libraries. We'll import pandas as PD, we'll import NumPy as NP, and we'll require matplotlib and cbon as well. So we'll just import that as well. So importing matplotlib dot pyplot as plt, and import cbon as SNS. Simple. If I just run this, and all we have to do is we have to just load that file over here. So the file name is car mpg students, and we'll just select this. I'll copy this path and I'll just read the data. .df is equals to pd.read underscore csv, and this is your file. And I'll just write on df.head. So this is my data, right? I'll just explain quickly what this data is all about. We have mileage of a car, we have cylinder, number of cylinder, we have displacement of that particular car, uh, HP, horsepower, weight, acceleration, year, origin from where it belongs, car type, and car name, right? So for example, the Chevrolet Malibu, it has 18 miles per gallon average. I'll just discuss what this unit is all about. It is miles per gallon. So in India, we use kilometer per liter, right? Kilometer per liter, right? In most probably in other countries like USA and Europe, they use miles for kilometer, right? So miles to kilometer, if you do, 1 miles is equals to 1.60934 kilometer. So 1 mile is equal to 1.60 kilometer, right? And what about 1 gallon? So gallon is also unit for fluid. So 1 gallon, 2 liter, if you see, it is 3.878 liter, right? So 3.78541 liter. 3.78541 liter. Is it clear? This one. So we have this miles per gallon, like it for 1 gallon, 18 miles this particular car travels, right? So what is our problem statement is we want to predict the mileage of a car by using all this independent variables. So this is a multiple linear regression problem, actually, not simple linear regression. This becomes your multiple linear regression, right? So the equation becomes y is equals to m1 x1 plus m2 x2 plus m3 x3, depending upon the number of independent variables that we have. It will carry forward to that particular point of time, and we'll be having c over here, right? So m1 x1 m2 x2 m3 x3 plus mn xn plus dash 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 up to c, right? Now what we'll do is we'll do exploratory data analysis, which is EDA, and which takes your for any machine learning project, it takes 80% of the time for any machine learning part, right? So this is very, very important part. In this EDA step, we clean the data, we make data ready for model building. So it takes a lot of time, right? So generally we'll check info of the data. We'll get an idea about the null values. So total we have 398 records. And if you just see this, we do not have any null values, right? For all the columns out there, we have 398 non-null records. So we do not have any null values in that. Second, so I'll write down there are no null values in the data. Then I'll write down df.describe to get the descriptive statistics idea. Then you can check skewness, kurtosis. Or if you do not do that, that is also fine. Then for the origin column, we will just check the value counts. And that is happen to be for origin 1, we have 249 cars which belongs to origin 1. And we'll just decode this data, what this data is all about. Origin 1 means it is America. Origin 2 is Europe. Cars from Europe are 70, and origin 3 is Asia. Asia. So we have 79 car belongs to Asia, right? Now what we'll do is we will plot the box plot to check the outliers. So detecting the outliers in the data set, right? So everybody knows this. How do we plot a box plot? I'm just setting a figure size of that particular figure by using plt.figure, and I'll write down df.boxplot vertical is equals to false. So it's just like we are setting a size of that output as it has to be 10 by 5. 10 belongs to length, 5 belongs to height. 10 belongs to length and 5 belongs to height, right? So that is my size. I'm just setting a size of that output. And as you can see here, if you just zoom a data a little bit, we have outliers in acceleration, we have outliers in HP column, we have outliers in MPG column, right? So when do we call a data as an outlier? Whenever we have data over here or over here, we call it as an outlier, right? So beyond this upper whisker region, beyond this lower whisker region, we have outliers. So 1, 2, here we have outliers. Here we have outliers, right? So we have outliers in the data. Perfect. We have to remove the outliers because we have seen what happens if we have outliers. There will be a misunderstanding, or the analysis will not be correct. Yes or no? So I'll just tell you a new method to remove the outliers. So you can remember this method, or you can use lambda function as well. So I'll create a function remove underscore outlier. In that, I'm going to pass columns. I will sort this column by using sorted column. Q1 comma Q3 is equals to np dot percentile column comma 25 comma 75, and IQR is your Q3 minus Q1. Lower whisker is Q1 minus 1.5 times of IQR. You know this thing. Upper whisker is Q3 plus 1.5 times of IQR. We already have discussed this in the last session, right? This is upper whisker, this is lower whisker. This particular is Q3. This line is 1.5 times of IQR. So this Q3 plus 1.5 times of IQR, it becomes upper whisker. And this is Q1 minus 1.5 times of IQR becomes lower whisker. Yes or no? Right? Now, the function is created. If I just run this, it will create a function. And in my data set, I have one categorical column, which is not needed. For our machine learning, we should have only numerical columns. We cannot build a model if we have a categorical column. So we have to convert, if we have categorical column, let's say different classes, we have to convert that into numerical. But here we have different car names, right? So total, if you just check shape of this data, we had 398 records, 398 different car names. So we have 398 distinct car name. And just to convert this 398 into numbers, it does not make any sense, right? 5, 4, 6, 7, 8, 9 up to 398. So you can convert that. That is known as encoding, that we are going to discuss separately in next sessions. But this car name, we have 398 different cars, and to convert that into numbers, this does not make any sense. So we'll drop this column. Also, it is not required, because if we have cylinder, displacement, HP, weight, acceleration, year, origin, we can directly get an idea about the car name, right? Because every car has special unique uh, features, right? So from this feature itself, we can easily get the car name. First point. Second point, my mileage is the target variable. My mileage is the target variable. So even though in that target variable, if we have outliers, that is perfectly fine for me, because I'm not going to use that to predict something, right? We want to predict mileage. So we'll not drop the outliers, in mileage MPG column. So we have left with only two columns in which we have outliers, that is acceleration and HP. So we'll check for acceleration and HP and we'll remove that, right? So from my data frame, how do we use this outlier function for, sorry, just a minute. Just a minute. Q3 plus 1.5 times of IQR, and return, we are going to return upper whisker and lower whisker. That is lower whisker and upper whisker. This function is created. Now it's time to call this function. For column in df.drop, I'm going to drop, as I told, MPG column, because that is a target variable. And second is car underscore name, right? Because this is not important for us. So we'll drop that. As we are dropping columns, so it has to be access equals to 1. And apart from this, in my data frame, I'm using all the columns except these two columns, right? So I'm passing a for loop for this particular columns, 1, 2, 3, 4, 5, 6, 7, 8, apart from MPG and car name. right? Apart from MPG and CAN. Now, lower whisker, comma, upper whisker is equals to, I'll pass remove outlier function that we have created. In order to pass this remove outlier function, what do we need to pass in that as an argument? Columns. So I'll write down df of column, right? Then df of column is equals to np dot where df of column, if it is greater than upper whisker, you are going to replace that with upper whisker, comma, df of column. And for all the df of column, np dot where, if my df of column is less than lower whisker, I'm going to replace that with lower whisker for that particular column. Simple. So if you do this, and if you just plot the box plot now, we had outliers in acceleration and HP. Now if I just take this after removing outliers, I'll not be having outliers in acceleration and HP column, right? So I'll just take this, I paste it over here. So do we have outliers now in acceleration and HP? We don't have outliers, right? So that is how you have removed. But MPG, it is totally fine to have outliers because that is your target variable, right? So we'll not do that. So that is what we have. Simple. Now, a very important part that we can discuss just uh, in very basic manner, because in tomorrow's session we'll discuss this. So suppose you have a data, like this. You divide your data into two parts, let's say X and Y. So for all the independent variables that you will be having, suppose these are the independent variables that you have, and this is your target variable. That is your MPG over here, right? So you divide your data into two parts, X and Y. Number of, what are the different columns that we had? MPG, cylinder, displacement, acceleration, year. Okay, these are the independent columns that we have. So we divide your data into two parts, X and Y. So this X will be having all the independent variables, and Y will have target variable in Y, right? And further, we divide your data into two parts, that is training and testing. So I can say, suppose this is my training data. This is my training data, and this is my test data, right? So basically what happens is, suppose this is your data, you divide your data into two parts. X will be having all the independent columns, Y will have target variable. You divide your data into two parts, so this becomes X train, this becomes X, this is train, right? And this is test. So this becomes X test, this becomes Y train, and this becomes Y test, right? Now, why there is a need of training and testing? We'll ask this question. Why do we split your data into train and test? So to understand this, we'll take one example. Suppose you guys are preparing for UPSC exams, right? And suppose there are two students for us who are preparing for UPSC exam. Let's say as part of training, one student A, has solved 100 practice papers, and student B has solved only one practice paper, right? So you have main UPSC exam, which is on 15th Jan, let's say. For if let's say uh, your student A, he has solved 100 practice exam. So on 15 Jan, he will be very confident to solve that particular main exam. And let's say uh, he has scored 90 out of 100 in that, right? And on the other hand, your B student, he has solved only one practice paper. So obviously he has very less chance to score high, right? So he has scored only 30, let's say, or 35, let's say, out of 100. So depending upon the training that you give to your machine, your accuracy will be high for testing, right? But if the training is very low, very poor, you will get poor accuracy in your testing. Yes or no? So in order to get a good accuracy for your model, your training has to be as high as possible, right? Training should be as high as possible, right? So that's the reason we have different splits. So we don't split our data into 50% train, 50% test. We don't do that. It is not recommended, right? It is 80-20, it is 75-25, it is 70-30, it is 90-10. Anything can be possible. So here 80 will be train, 20 will be test. And likewise here 90 will be train and 10 will be test, right? So depending upon the training that you give to your model, your testing will be good, right? And there is one more thing. We use train set to train the machine learning model, and we use test set, which is completely hidden to your model to test the model, right? And how do we test the model? Very simple. How do we test the model? Is we generally suppose you have 700 data points. In this data itself, we have 398, right? So let us take this example. We have 398 data points. So if you do 70-30 split, that is 70% will be 70% of 398 will be 278. So let us take 278 will be training, and remaining 398 minus 278, which becomes, I think, 120. That will be a part of testing, right? So you'll train your model on this 278 data point, and there will be a test set which you already have, right? But we don't show this to your model. So suppose this is a Y test. These are the 128 data points. We don't show to this model. What we'll tell this will tell this our model to predict this Y. So we already have Y values. We don't show that to our model. We already have this value. So suppose 18, 15, 18, 16, 17. I'll just take this 18, 15, 18, 16, 17. 18, 15, 18, 16, 17, 18, 15. Just consider these are the 128 data points. We don't show that to our model, right? And we'll ask our model to predict this, what is there in this, right? So we'll be having different columns like cylinder, displacement, HP, weight, acceleration, year, origin, car type, but we'll not show this 18. So likewise, for 120 data points, we'll not show this to our model, but we'll show this thing. And we'll ask to our model to predict this value by just training the model, right? So for an example, my model has correctly predicted 18, 15, this is 17, this is 16, this is 16, suppose, this is 18, this is 15, this is 17, this is 19. So let's say out of 128, my model has only predicted 120 correct, right? 120 correct. So what will be your accuracy? 120 divided by 128, simple. So your accuracy will be 93.75. So you can say that if I don't show 128 data points to the model, My model is still predicting 120 correctly, and my model accuracy is 93.75%. So I can easily use my model to predict the future data, right? This is your past record. Yes or no? Why we are using machine learning is to predict the future record. Suppose in your data, in future, you'll get you will get a new car. Let's say you have got 5 new data points. You have got 5 new data points. So let's say cylinder is 5, displacement is 200, HP is 150, weight is this, acceleration this. Your model will predict 94% accurately. Your model will predict what will be the mileage of that particular car, right? Because your accuracy is 93.75%. So your model will predict 93.75% accurately what will be the accuracy of that new car. What will be the accuracy instead of accuracy? I can say mileage, right? Because we are predicting mileage. So what will be the mileage of that new car? Simple. Now is it clear how it happens in the back end? Everything is clear to you? So we are going to discuss trend split, right? We have discussed trend split, and that's the reason I have discussed why do we go with the trend split, why training should be higher, and how do we hide our training testing set, and how your model predicts, and what will be your accuracy, right? Now it's time to do trend test split in Python, right? So it's a code, very simple and basic code. You only have to remember it one time. For all the machine learning models, for all the models out there, you are going to use this same thing. So you only need to remember one time. And suppose I don't know the trend test split package, right? So what I'll do, I'll write on trend test split sklearn package, and I'll just simply take that package from the official documentation of sklearn. So you don't need to be aware about the package. You don't need to learn this by heart. You can go to official documentation. There itself will find different parameters and how do we import the package. So I can take this help from sklearn.model_selection, import trend test split. But as you practice this, you'll become habitual to this and you'll remember what will be your package, right? But as of now, if you don't remember the package name, you can directly take help of the official sklearn website and to import the package. Now, as I told, after trend test split, you have to divide your data into two parts. X, in X, you have all the independent variables. So in our data, what is your target variable? It is MPG, and car name is your text data, right? Categorical. So you don't need that. You can remove that. So in X, what do you have? All the independent variables, right? In Y, what do you have? You have only target variable. Yes or no? Do you remember this? We have discussed this. In X, you have all the independent variable. In Y, you have the target variable. So you have done that. Excellent. Now what you'll do is you'll just check what is there in X. Is it correct or not? In X, do you have all the independent variables? Just check. Yes, I have all the independent variables. So that is fine. Now it's time to do the trend test split. And in this thing, you do the trend test split. So you write down x underscore train, x underscore test, y underscore train, y underscore test is equals to y. It is equal to the package trend test split. In that you pass x, you pass y, you pass test size equals to 0.3. It means if my out of 100%, if my 30% is test, so what will be the training part? What will be the training set? It is
0.7.
0.7. Very good. So we are doing 70-30 trend test split, right? And as I have discussed why it is needed, because training has to be as high as possible. But it's not the case like 70-30 means generally you can use 80-20, 75-25, 70-30, 90-10. Anything is fine. This is just a trial and error method. So I'll just use 0.3. And what is random state? As of now, I'll not discuss that. It's very important and it's very interesting. So I'm not going to discuss that, but we'll discuss this in tomorrow's session. What is random state, right? So as a part of your homework, you can take this. You have to read about random state, and you can come in tomorrow's session. We'll discuss that. Right? What is random state? Now, very important thing is we'll check shape of the data. It is 398, right? And as we are doing 70% split, so 0.7 of 398 becomes roughly 278. My 278 data point should be a part of training set. So if I just check shape of train, it is 278, and remaining 120 should be a part of test set, right? Remaining 120 should be a part of test. Simple. Now it's time to go with the model building part. Again, a very important step. I'll give you very easy method to build a model. And obviously, if you use that, that is totally fine. You don't need to go ahead with the uh, complex part or cosmetic part. Very simple, plain vanilla model is also equally important or equally effective, right? So you don't need to go ahead and do a very fancy method. I'll teach you fancy method as well. But as we are learning this very first time, I'll tell you very simple and effective way to fit the model. Right? Very simple and effective way. There are certain methods. You can use n number of graphs, charts, and whatnot, which is not at all required. You can use this four steps of simple model building part. So what is the first step? Remember, you have to learn this, by heart this. First is object creation, second is model fitting, third is model prediction, fourth is model evaluation. So these are the four stages that we have for the model building. So very first step, we'll do that. Step one, which is object creation. Now, for this, you will require linear regression package, right? Because we are using linear regression. So we have a linear regression package in math in sklearn. So if you just search linear regression, you don't need to worry about this if you don't know. You direct search linear regression sklearn, and you can copy this package, that is from sklearn.linear_model import linear regression. You can copy this, right? And you'll create an object. So object creation is, you'll create object instance, model is equals to linear regression, open and close bracket. You'll fit that model by using model.fit. You always fit it on X train and Y train. Remember this. So that is your model fitting. Yes or no? So I can say step number 2 as model fitting. Now it's time to go for step number 3. It is model prediction. Right? So you'll write on y_pred is equals to model.predict. You'll pass x_test. As I told you, we only hide the y test, right? We don't show y test to the model. We will not show the, suppose these are 128 records, just for an example, these are 128. So we'll not show this, but we'll show this to our model. All the independent variables will show this, and we'll ask to predict this, right? So that's what we are doing. We are showing X test to our model, and we ask that model predict Y value from the X test which is provided. Simple. So if you just check Y pred, so for Y test, see, this is the, see, first 277 is 16.2, and these are your Y pred. So if you just compare Y pred with Y test, you'll be able to get the answer. So your first value, model has predicted 33.57. And what was the actual value? It is 33, right? So model is going good. Then second value is 28. Model has predicted 30. Third is 19. Model has predicted 19. Then 17, 13. Then 13, 14. So likewise, you can compare to this model, right? But you don't need to do this manually. You don't need to do this manually because uh, it's very difficult, right? To compare 398 Y test with Y pred. And just compare, this is correct, yes, this is correct, yes. So you have to call a package for that. As I discussed R2 score, so we'll just call a package. Now again, for R2 score, we have a package. If you don't know how R2 score works, or what is the official package for that, you'll directly go to this R2 score and you'll copy this. So the package from sklearn.metrics import R2 score. That's how you have to remember. It's not very difficult. You can directly take reference of official documentation of sklearn to import the packages, right? So I've imported R2 score. Now I'll find R2 score. It's just like your accuracy between what. Remember, we always check Y test and Y pred to check the accuracy, right? We always compare Y test and Y pred to compare the accuracy. And what is my accuracy? It is 86.41%. So I can say my R2 score or R scored is 86.41, which means my independent variables are 86.41% capable to predict the target variable. And then you can find root mean squared error. So there is also one package in sklearn.metrics, that is mean underscore squared underscore error, right? So what I'll do is I'll write on np.square root sqrt mean underscore squared underscore error between y underscore test comma y underscore print. So my mean squared error, that is RMSC, is coming out to be 2.79. So this was your mean squared error, right? This was just a example that I've taken, dummy example. Any random data. For that, root mean square was 5.56. Here it is 2.79. Now I'll ask one question. You tell me, for a good model, what should be the mean squared error? Is it high or it should be low? This is root mean squared error. This is square root, right? Square root of mean squared error. That is root mean squared error. You tell me what should be the root mean squared error. It should be high or it should be low for a good model. What do you think, guys?
It should be low.
It should be as low as possible. Then only you'll say that that is the best model, right? Because that is an error. Error should be as low as possible. R2 score should be as high as possible because that is the accuracy, right? So I can say R2 score should be as high as possible. Simple. Clear? So there are several techniques to increase the accuracy and whatnot. We're not going to discuss that as of now because I wanted to have this a very plain and simple discussion because this is our first session for machine learning. As the session progresses, we are going to go in complexity. We will not discuss the ways to improve accuracy in this session itself, right? But we'll do that definitely. We are going to discuss that. Now, do you guys have any questions till this point of time? Anybody have any questions? Any doubts? Yes, guys. Anybody have any questions? Any doubts?
Yes, Vipul. Yeah, in the we are predicting what Vipul, we are predicting the mileage, right?
Hmm.
Yeah, so I understand the Y train and Y test and X train and X test, that is okay. But we are how we are telling to the model which is the answer, Vipul.
See, we have predicted this, no? And this is already present.
Oh, the mileage column already
3.
present. Okay, based on that we are training. Okay, okay, okay.
Your model has predicted 33.
Okay,
And if you just check last
okay,
5
okay.
YTEL,
Mm,
ytest.tel. So last is 16.2, it is 19. Then it is 37.31.
mm,
It is 20.6, 20.89. Model has predicted 26.51, it is 26.
okay, okay,
So we are just
okay.
comparing.
I thought we removed the columns. That's why I asked. Mm,
No, we have not removed, no. We are
okay,
just
okay, okay.
predicting Bayesian
Mm,
X. And what I told you to is your Y test is completely unseen to your model. This is Y,
mm,
this is train, this is
mm.
test. So Y test is
Okay,
completely unseen. We don't show this to model. But we
okay,
are
okay.
this X test entire data and we asked to
Mm,
predict Y test. We asked to predict
okay,
this
okay, 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 okay.
and suppose it has predicted Y pred. So we just
Mm,
compare the two and we find the accuracy.
okay, 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 okay.
Simple. So it's just like
Mm,
you have given 10 questions
mm,
and you don't have solution with you. You have solved that 10 questions and then we'll check the accuracy. Like out of this 10 questions, you have solved 9. So we'll just
mm.
compare this.
Okay, okay, okay. Okay, Vipul.
Yes. All right.
Thank you. Thank
Good question. Good question.
you. Thank you.
Yes. What about other guys? Yes, Darshini, Abdul, Arvind, Arun, Arivoli, Chandramohan, Gopi, Ishwarya, Kanan, Madhu, Maulya, Murali, Prashant, Sharmila, Varun, Karthik, Venu, and Vijaya. Yes, guys. Do you have any questions? You still have for 20 minutes to ask questions. If you don't have, we will stop here for the day. You just revise everything whatever we have discussed. And I have told you very simple way to fit the model, right? I've not told you any fancy way, and it's not needed, right? And in tomorrow's session, we'll go in detail about different ways to fit the model. I'll just tell you some other alternatives as well, and we'll see the next part, right? And there's one more thing that I can tell you at this point of time, which is, suppose I want to check the training accuracy, like what is my training accuracy? So what I'll do is I'll write on y underscore train underscore trade. I want to predict y train. So I'll use which subset? I'll use x train to predict what is there in y train, and y test pred, which we already have discussed, which we already have predicted by using x underscore test, right? And I will print by using f string. The training accuracy is R2 score of y train and y pred, and testing accuracy is R2 score of y test and y pred. Simple. Just a minute. The string should be here. It should close here. And this should also close. Here. And this is not needed. If train accuracy is this, so test is this. Okay. So my training accuracy is 82.80, but testing accuracy is good, 86. And there's one rule that there should not be more than 5% difference in the train and test accuracy. If it is there, it means that your model is poor, right? More than 5 or 6 is also acceptable. So what I'll do is I'll just subtract it, 86.41 minus 82.804. So it is 3.60. So it is 3.60 and it is acceptable. The difference between training and testing accuracy is this. Simple, right? So that's how you can calculate the training accuracy. Here we have calculated the testing R2 score, right? Right. We'll calculate training R2 score as well, which is 0.8280. Okay, so I'm waiting for your question. You have any? We'll wait for 5 minutes. If you don't have, we'll stop here for the day. All right, then if you don't have any questions, we can stop here for the day. Are weather apps based on regression models or classification models? They also provide the probability of rain and update us in real time whether it's raining or not. See, if it is quantity, then it is a regression type of problem. But rather than this, it works with the separate. It works on the separate module which is known as forecasting. So you will get to learn that time series forecasting or forecasting, right? So it's not. We cannot say that we use regression or classification. We use forecasting in that. And this your drive on your drive, I already have shared everything, right? So if you want collab file, if you want anything, if you want theoretical part, you can discuss it over here. You can get over here, right? Yes, Kannan, you already have this on your drive.
Yeah, I got it.
All right. Excellent. All right, then I think all clear. We can stop here for the day. Tomorrow we'll continue with the next discussion. So thank you and happy learning. Bye.
Yeah. Hi, sir. This is Arvind from GUI, Mental Mentor. So I would like to take 5 to 10 minutes time of the students, sir. Just need to.
Yes, sure, sure.
Sir, are you there, Vipul? Sure.
Yes, yes, I'm audible.
Yeah, you are audible now. So I just want to discuss with the students for 5 to 10 minutes.
Yeah, fine, fine. No problem.
Yeah. Okay. Yeah. So hello everyone. Good morning. So this is Arvind, your internal technical mentor. So hope we discussed right regarding the first project. So how is it going on? So I hardly get any queries. So what I try to understand how the project is going on, how how difficult is it or is it easy? I just wanted to discuss that thing, and I also wanted to give you the next glimpse for the next project. So I just joined the session. So can I get feedback from every one of you?
I have completed my project, sir,
Yeah, good, Murli, good. Okay.
and I needed to upload it in GitHub.
Okay. That's good. Okay. How about others?
Sir, I have created my project. I have completed my project. Sir, am I audible, sir?
Yeah, you are audible.
I'm also completed my project, sir.
Okay, good. Very good, Gopi.
Sir, I
Yeah.
created the three files, so I have to submit the three file links in the submission block, sir.
No. See, you need to update all your project files, project related files into your GitHub repository. Only the GitHub repository link you need to submit.
Repository link.
Yeah, depository link only.
Sir, if we book the slot
GitHub.
for sir, if we book the slot for this evaluation, so tomorrow I think I will get the link, right, sir? Hello, sir.
Oh,
Connect with my internet.
yeah, sorry, it's my internet problem. So just give me a minute. So any other person want to tell anything?
Sir.
Yeah.
Sir, today I will book my slot for evaluation. I think tomorrow I will get the link, sir. Is it?
Sure. That's good. I can see people who has solved more number of code kata are doing the project. So other people are bit quiet. Okay. So can I
Sir,
go
after
ahead with yeah,
after to book the slot.
Gopi? Yeah, Gopi. Gopi, come again. You are not audible now. Okay, shall I proceed with the next project? Like it's not a project orientation. So your next project will be assigned after 15th only. But you need to learn few things before you do the second project. So I thought it's quite important for you guys to learn the necessary skills before you start the project. So what I joined in the session. So shall I continue with that? Or you want to discuss about the running project?
Yeah, let's have a discuss about the running project, sir.
Okay, yeah. Tell me, what's the struggle or issues that you're facing?
Yeah, sir. Actually, the product is the Zomato data insight, right? So, we do we need to focus on creating the UI, or we can have a data in the database mockup, and we can proceed with the backend works like the plots and everything. So, is that the UI is mandatory?
UA is the mandatory because you are going to do the database management. Okay. So
Okay,
analysis is secondary.
okay,
Yeah.
okay.
So
Thank you, sir.
yeah, UA is the
So,
major thing. Yeah.
UI is the major thing.
Mm.
Okay, sir.
So like I showed you in the demo, right? So in the Streamlit application, all your CRUD operations has to be proper. Okay. Any other question regarding the running project?
Okay, sir.
Yeah. Anyone else? Okay. Shall I proceed with the next one?
Just give an introduction about that. What would be the one like that, sir?
The next one, right?
Yes, the next one.
Okay, fine. Yeah. So this project is about web scraping. Okay, so have you all known about the web scraping, like collecting the data from the internet? Have you guys know about that?
I think fetching the data from website, like fetching the address and company name from the just style or something like that.
Yes, exactly, correct. Okay, so why the next project is about web scraping in the sense? Okay, so the currently in India, startups have been increased. Okay, so for working in startups, even if you're working as a data scientist, you need to provide the necessary data. Okay, so data engineers role are very less, so and the demand is huge. So nowadays, industries are demanding this particular web scraping skill as well. Okay, so what we have included this particular web scraping tool into the projects. Okay, not into the syllabus, but it will be working in the project. Okay, from the last quarter. Okay, so it's a separate tool. All you need to know is just 3 to 4 points which I will mention you here. Okay, try to learn only those things. Do practice for the next week. Okay, so after completing this first project, we will assign you the web scraping project. Okay, so I'll share you few recording links related to that. Okay, so this is English recording. I will also provide you the Tamil recording. If anyone want to utilize, you can utilize that as well. Has everyone get the link from me? quickly confirm. So I don't want to waste your extra time. Okay, I'll share my screen and I'll try to, give a quick intro and also a task to you to complete and practice. Is my screen visible?
Yeah.
Okay. Okay, so get into this Redbus website. Okay. And get into the particular APS RTC. Okay. Get into only this Hyderabad to Vijayawada. Okay. Take this hyperlink. Okay. It's a task. Okay. It's not a project. It's a task for you guys. So you need to collect the bus data from here. So what is the data that we can collect? Anyone? Please tell me. What are all the data that we can collect from this website?
The bus name, the time of
Bus
the
name.
arrival. Acha.
Okay. Bus name, time of the arrival. Then
Duration of the bus travel.
okay, duration of the travel. Then
Travel cost, sir.
travel cost, bus fare, right? That's what you mentioned. Okay, fine. Next, what other data?
Available seats.
Available seats. Okay. What Chandramohan? Departure time. Okay. Arrival time. Then
Amenities available.
amenities available. Okay. Then
Type of
Then
bus,
bus
AC or
ratings.
non-AC,
bus ratings. Very good.
sleep,
Then
type of seats, type of
type
bus,
of
AC
seats.
or
Okay.
non-AC.
Good. So almost if you take a single bus, no, you can take almost like 10 to 12 different data, right? So what are all the data types that we can get it from this particular bus? Data types. I'm asking about the data types.
Date, time, string.
Daytime string, okay. String, okay. Daytime index string, then
Float, integer.
integer float. So all data types that we can collect from here, correct? Okay. So I want you to do a practice before you get into the next project. Okay. So try to collect the data. What are all the data that are available in this particular page? Okay. So you need to align the data into a data frame. Okay. So data frame in the sense under the bus name column. So NeoGo should be there. Intercity Smart Bus should be there. Intercity Smart Bus, YOLO Bus. So 1, 2, 3 kind of in the name column, it should be there. Okay. So when it comes to departure time, 23:45, 00:15, 22:15 should be there. Okay. So like that for each and every column. Okay. For specific buses, the proper detail should be there. Okay. You got my point? Guys, so if you keep on scrolling now, you will get more buses. See, so everything should be written in Python. Okay, so the data collection alone, you will use the tool name Selenium. Okay, it's a very simple tool, a very, very simple tool. Okay, fine. So if possible, okay, you can also take, these are all private buses for the route Hyderabad to Vijayawada. If possible, and if you are, very much interested, you can also collect the data from government bus details as well. See, the APSRTC buses, there are 105 buses are there. Okay. So for TGSRTC buses, 80 buses are there. Okay, so how you can collect these buses in the sense, if you click the view bus button here, these TGSF buses are opening. Okay, so if you click the view buses for Andhra buses, APSRTC, again you will find details for APSRTC buses as well. Okay, if someone is interested to learn more things, then you can, take the APSRTC bus, these government bus details as well. Okay, otherwise for practice just collect the private bus detail along. Okay guys, fine. So this is your task. I will, I'm remembering you again, it's not your project, this is just a task for you to practice. Okay, fine. Now I'll tell you quickly what are the 3 to 4 things that you need to learn in the Selenium. Okay, so where will I write? Let me open one Excel. Okay, so first thing you need to learn. Okay, suppose if you want to take a bus name, this fresh bus name. Okay, you will learn these things in the recordings. Okay, so from here, these are all the tags. Okay, the tags they will tell. Okay, CSS selector they will tell everything, they will tell. Okay, but all you need to know is for taking this fresh bus, what is the XPath that you need to learn. Then again, you will learn what do you mean by XPath. Okay, so try to learn how to write a XPath or CSS selector or class name. Okay, this is the first thing that you need to learn. Okay, the second thing that you need to learn is how to convert this into your XPath into text or hyperlink. This is the second thing that you need to learn. Please note it down or you can take a screenshot as well. Okay, third thing that you need to learn is how to save the collected data into a dictionary, a list of dictionaries. Okay, list of dictionaries. This is the third thing. Fourth thing, how to convert into data frame. Okay, fifth thing is expected condition concept. So these are all the 5 things that you need to learn in Selenium. No other thing you need to break your head. Okay, and to complete the project in Python also you need to be, thorough with few concepts. The one thing is for loop. Okay, second is try and except statement. Okay, third is functions. Okay, and fourth could be if condition, if statements. Okay, and what else? Fifth may be class and objects. Okay, so again the project is going to be done only using class and objects. Okay, so have you guys noted it down? Yeah, any response? Can I put it in the chat? Yeah, noted it down.
Yes, sir.
Okay. Good. Okay. So it's a very simple concept. Okay. You don't need to break your head. Okay. This is very new. This has not taken in the classes. So you don't need to break your head. Just try to understand or thorough in these 5 concepts. Then you will be easily able to complete the project using these 5 Python skills. Okay. Fine. Okay. So I can see, I'll also share a sheet with you guys. So no, I don't want to share. I'll tell you, I'll stop sharing. So try to improve your code kata skill. Okay. So code kata, there is not much improvement in each of you. The same amount of code kata score for the last week and the current week is okay. So I can see Gopinath is the topmost guy who completed almost 94 Kolkata. Okay. So what he is able to complete the project before everyone. Okay. So the same with Murali Krishna. So Murali Krishna has completed almost 60 Kolkata. So he has also completed the project. See, Kolkata is the only thing that will help you to improve your skill as well as your confidence, and it will help you to complete all the projects without taking any burden. So try to improve your code kata. Okay. So put more and more efforts in the upcoming weeks. Okay. So every week there will be projects will get assigned. You will not get much time on completing it. Okay. Fine. Yeah. So any doubt?
This is the last week for the project evaluation.
Oops. Yeah, this is the last week for the first project. I think 15th was the last date, right?
For evaluation, up to 15th is the last week.
Yeah, evaluation you need to book the slot.
Hello, sir. Myself, Jetli.
Yeah, hi Arun Jetli.
Sir, actually, last weekend classes, I'm in hospital, sir. I'm unable to attend the classes in the special project session.
Okay. The last project, huh?
Yes, sir, last one. In my web portal, only one project is for me.
Yeah, only one project has been assigned. This is the upcoming project. Okay. So I just want to give you guys a prior experience to do the project. So I just jump in. It's not from the GUI, so it's from my side. I'm just giving you a task. That's all.
Okay, sir. Okay, sir. But for main project, that session I missed that, sir. So that's why I'm asking what
Yeah,
should
only one project has been assigned as of now, Arun. Okay. So that is Zomato.
Okay.
Yeah. So next project will get assigned after completing the first project.
Okay, sir.
Yeah. Fine. Any other doubt?
Sir, thank
Yeah. So can we wind it up then? Have you guys copied and saved the link of the tutorial?
Yeah, yes, sir.
Okay, sure. Fine then. All the best. Thank you. Have a nice day. Have a nice weekend. Thank you, everyone.